All right, so I have the mini exams here. I'll pass the stack around. Again, there's no grades on these. The grades are online, so if you have questions, let me know. Significant difference on these. And I did put a note on the top, I believe. If I put the word NEAT, N-E-A-T, NEAT, and then +3, I gave you a bonus just for me noticing that you took some time to make it look good. So much better, much better. So there you go. All right, I'm going to go ahead and get started, try and get through this Lagrange stuff. So what we saw last class was that there is this method called Lagrange where we can find the maximum and minimum values of a function if we set up a system of equations, right? And for a function of two variables subject to one constraint, we have how many equations that we'll set up? 3. There will be 3 equations we set up. I'm putting them off camera here because we're going to use them. The first equation we have is that the partial of f with respect to x must be equal to lambda times the partial of g with respect to x. The second equation that we'll have to solve is the partial of f with respect to y must equal lambda partial g with respect to y. And the third equation is that, well, your constraint has to be true. G of x, y must be k. All right. So that's what we need. Now, I did not get into a proof as to why this is true, right? I do have a visual proof for it, but I still just want to keep grinding on this so we can see this. And if we have time, I'll show you the visual proof at the end. So for this example, everybody see we have f of x, y is 4x plus 6y. That is a plane. So here's a plane. And what we're doing is we're restricting it to only the values of x and y that live on this circle. So the domain is right here on the ground, like that. If we plug just the points on that circle into the surface, we get that, what looks kind of like an ellipse, kind of, right? On the plane. You'll see that ellipse on the plane? Is that it? Thank you. And what we're trying to do is figure out the highest and lowest points on that blue ellipse. So let me take all that out. So there we go. So we're trying to find this highest and lowest point. So it looks like from the visualization of it that we should get a highest and a lowest point. Now, how do you do it, right? How do you actually find those points? So we set things up, right? All right. Partial of f with respect to x. That's equation 1. Partial of x, f with respect to x. What do y'all think? Pretty nice, huh? So I'm going to write partial f with respect to x, lambda partial g with respect to x. So just 4 equals lambda. What's the partial of g with respect to x? Remember, this is g, right? That's my g function right there. So what's the partial with respect to x? To x. All right, that's a nice equation there. Equation 2, partial of f with respect to y must equal lambda partial g with respect to y. So partial f with respect to y is just 6. Lambda partial g with respect to y is 2y. Off to the races here, I think. This is pretty nice, right? Would you all agree these are pretty clean equations? My third equation is just the constraint. X squared plus y squared must be 13. All right. Now, one thing we can do is we can divide by a constant. So I can make this 2 equals lambda x. And over here I can divide by a constant, make this 3 equals lambda y. Remember, we cannot take this and say, all right, lambda has to be 2 or x has to be 2, right? It only works when it's 0. So what can I do? Well, here's something I can do. Let me see about trying to solve this for x. If I solve this for x, I have to divide by lambda, don't I? But then I have to promise that lambda is not 0, right? Because then I have division by 0. So I'm going to start here first. Suppose lambda is not 0, all right? Just letting you know lambda is not 0. Now, if lambda is not 0, equation 1 tells me that x is 2 over lambda, right? I could divide both sides by lambda. Similarly, equation 2 tells me that y is what? 3 over lambda. And now, if I go to equation 3, I can replace x with 2 over lambda, replace y with 3 over lambda. And now, won't I have a single equation with one variable instead of 2? And I should be able to solve for lambda. And if I know what lambda is, won't I know what x and y are? If I know what lambda is? Okay, so let me continue. Square this. This is 4 over lambda squared, plus this is 9 over lambda squared, equals 13. They already have the same denominator, don't they? Put them together. So 13. 13 over lambda squared equals 13. And there's all sorts of different ways to solve this. I'm just going to get to lambda squared is 1. Right? You can multiply both sides by lambda squared, then divide by 13, plus or minus 1. Lambda is plus or minus 1. All right, so let's now look at some scenarios. Remember what we're trying to find, and I told you try not to get confused with this. We're trying to find like this triple where it gives us the x, the y, and the lambda, right? So let's start with lambda being 1. If lambda's 1, what's x, what's y? So if lambda's 1, what's x, what's y? 2 and 3. Now, if lambda is negative 1, we get the opposite, right? Negative 2, negative 3. Questions on that? If I have a max or min, this is potentially where it could happen. All right, what should I do now? That was all under the assumption that lambda wasn't 0, right? Lambda wasn't 0, and I was able to get some answers. Now I'm going to look at what if lambda is 0, right? So I'm going to have a new suppose lambda is 0. And right away you have a problem. You'll see the problem? Look at your equation 1. What would that mean? Equation 1 would mean 2 equals 0, which is not true. So lambda can't be 0. So I don't need to look any further, right? If lambda is 0, then 2 is 0. That's not right. It's not true. So have we considered everything? I think we're good, right? We wanted to take these and solve for x and y. The only way to do that is to make sure that lambda is not 0. We did that. We got only 2 answers. And so this should be where we get the max and min, right here. So to find the max and min, right, what we're going to do is we're going to take those points, we're going to plug them into the original function. And just remember, we're only plugging in the x and y. So 2, 3, and negative 2, negative 3. Those get plugged into the function, the original surface, and we should be able to get our result. So plug in 2 here, plug in 3 here. What's that? 26. And then if I do negative, it'll be negative 26. There we go. This is your max. This is your min. That was pretty straightforward, I think. Would you agree? Just making sure to look at when lambda's, you have to say lambda's not 0, or else that's not true. I wonder, is there another way we could have done that? Can I show you just a different way? Because there is no perfect way, you have to do it. I want to try something else that maybe a student might have tried. What if someone instead came in and said, hey, you know what? Instead of solving this for x, instead of solving that for y, what if I solve them both for lambda? How about that? I solve them both for lambda. So if I solve this for lambda, I have to promise you that x isn't 0, right? If I solve this for lambda, I have to promise you that y is not 0. So I would have started like this. Suppose x is not equal to 0 and y is not equal to 0, right? Let's suppose they're both not equal to 0. Then equation 1 tells me what? Lambda's 2 over x, right? And equation 2 tells me that lambda's 3 over x, right? Or 3 over y, sorry, 3 over y. And now that I have that, I can set those both equal to each other, can't I? Since they're both equal to lambda. So that would imply that 2 over x equals 3 over y. And if I kind of cross multiply, this would mean that 2y equals 3x, right? And I could go further and solve this for either x or y. Let me solve for y. Y is 3 halves x. We agree? Now I can take this and I can go to equation 3. Equation 3 tells me that x squared plus y squared, but what's y? 3 halves x squared must be 13. And now if I square that, 9/4 x squared equals 13. And if you get a common denominator over here, you get 13/4 x squared equals 13. And if you solve for x here, you can get plus or minus 2. Right? You'll get plus or minus 2. Do I need to show that, or are we good? Let's see that. See that? So you get plus or minus 2 multiplied by 4 divided by 13. Okay, so now you have the two different scenarios, right? What if x is 2? If x is 2, where do you get y from? If x is 2, right here, right? If x is 2, then y is 3. If x is negative 2, then y is negative 3. You see how you could get the same thing? And you could also figure out what lambda is from that. So you see I get the same results. Now, I would also have to look, suppose what? X is 0 or y is 0. Well, not going to happen. Same reason, right? From here, equation 1 would have to mean 2 is 0. Not true. And then same with the other one. 3 is 0. So you don't even consider those. I'm just showing you. See, there's kind of a slightly different approach there, right? But we get to the same result. I hate grading these. These are the hardest to grade because I never know what path a student's going to take, right? So I have to make sure they're going the right. I mean, the way they go might be right. I just have to follow the logic through, right? The thing you want to try and be careful with is make sure you're not missing anything, right? That you're not forgetting to take something into consideration. Because even though you might get the answer, it might be correct, if you forgot to look at one scenario, then technically that's not right. Because it could have been that other scenario actually turned out to be your max or min, as opposed to what you did. All right, I need to spray this. Next one. Find the max min. There's your surface. There's your constraint. Looks, it's not a quadratic, right? Or it's not a circle there at the end. X cubed plus y cubed equals 16. F of x, y is e to the x, y. Let's get our equations. Equation 1. Okay, partial of f with respect to x equals lambda partial g with respect to x. This is our g right there, right? All right, let's take turns. Who wants to tell me that equation? First, and you get to volunteer, and then you have to wait until it's your turn again. So who wants to tell me what that equation is? Just read it out to me.
F of x is e to the xy times y.
E to the xy times y equals lambda
3x squared.
times 3x squared. Good. All right, who wants equation 2? Who wants it? Okay, go ahead. So e to the xy times x and then equals lambda 3y squared. There you go. Okay, got our first two equations. The third equation, you should never get the third equation wrong, right? Because it's the given constraint. Equation 3, x cubed plus y cubed is 16. Okay, what to do, what to do? I'll give you a moment to look at them. Anyone have any questions over those equation 1 and 2, where they came from? No? Okay, any suggestions? Or, I mean, I'm open to doing whatever. Just needs to be legitimate algebra. You want to solve for x or y? For which, the first one?
Sure.
So you,
Divide lambda 3x squared by dxy.
okay, you're saying solve this for, well, if you solve that for y, then y is going to appear on both sides, right? Because the y is up here as well.
Okay.
I see what you're saying,
Yeah.
but you don't want to solve for y in terms of itself. You don't want a y to appear there as well.
Natural logging.
Oh, yeah, you could start getting into that. I think that, but it might be way more than you want to do. Because if you natural log that, you got to natural log that too. So then now it's trapped in the log over there, right? Solve for lambda? We can solve. Can you solve for lambda here? Okay, can you solve for lambda there? Then we can set them equal to each other? Okay, that sounds fair. If we do that though, solve for lambda here, you have to divide by what? 3x squared, which means you have to promise me x is not 0. And if you solve for lambda here, same thing, right? You have to promise y is not 0. So that's what I'm going to start with. I'm going to say, hey, suppose that x and y are not 0, and then I can do this, right? So suppose x is not 0 and y is not 0. And just as a kind of getting ahead of ourselves here, do you all see that in this one it looks like maybe x could be 0? Like before, remember it was like, then it would say 2 equals 0, and that doesn't make any sense. Do you see if x is 0, it is actually possible that the other side is 0? Like if y is 0, then it works. So yeah, let's start with this. Suppose x and y are not 0, then equation 1 yields that lambda is e to the xy times y over 3x squared. Right? That's just dividing both sides by 3x squared. Equation 2 tells us that lambda would be e to the xy times x over 3y squared. And then I can set them equal to one another. So I have e to the xy times y over 3x squared equals e to the xy times x over 3y squared. And I should be able to get rid of the e to the xy. Right, I can divide that on both sides. E to the xy will never be 0. So I can divide that out, right? I don't have to worry about that. That is important, that e to the xy can never be 0. If not, I would have needed to move everything over and factor it out. But because I know it can't ever be 0, I'm going to divide by it. And let's see. Let's continue over here. I have y. Okay, what do you say? Oh, I could have multiplied by 3 too, right? Also? You want to get multiplied by 3 on both sides? Just get rid of the 3. Can I multiply, like that cross multiply thing, can I make this be like y cubed equals x cubed?
Yeah.
Yeah, because I've assumed that x and y aren't 0, so I can multiply both sides. So this just tells me that x cubed must equal y cubed, and that's pretty freaking nice because if x cubed equals y cubed, then when I go to this equation 3, I can replace x cubed with y cubed. So that means from equation 3 that what? Y cubed plus y cubed equals 16, which means that 2y cubed is 16? So y cubed is 8? And if y cubed is 8, y is 2. Not plus or minus, right? Because cube root. So y has to be 2. And if y is 2, right, then according to this, x is 2. But that implies that x must be 2. I'm continuing here. Y must be 2, which means, y'all understand I'm getting that from that, right? If y is 2, then that means x cubed is 8. And that means x is 2. All right, this is looking pretty freaking good. What about lambda? Oh, could I figure out what lambda is? I could, right? So like if I'm trying to do my lambda stuff here, like x, y, lambda, I know that x is 2, y is 2, right? And lambda, I don't know yet. I would just plug it in right here. Now, do I need that though? Do I actually need to know what lambda is? It's not going to factor into anything, right? Because all I would use is the 2 and the 2 to plug into this to get my max or min. I don't actually need lambda to figure out what the max is. So I'm just going to say here, like, yes, I know that there is a lambda, but I really don't care. It's what, e to the 4th times 2 over 12 or something. E to the 4th over 6, who cares? It's some number. It's not relevant to us, other than we need to know that it exists. Okay, we good? Okay, are we done? No, because all of this was based on the assumption that x is not 0 and y is not 0. So be careful with this next step, because what I need to do now is kind of address those one at a time. So let's just suppose that x is 0 first. Suppose x is 0. If x is 0, then what happens? That means this, let's go to equation 1. That means that e to the 0 times y must be 0, right? And e to the 0 is 1, so that just means y is 0, right? Do you see that it forced y to be 0? It forces y to be 0. Similarly, if you did y is 0, right, wouldn't that happen here? It would force the x to be 0. So it looks like if x is 0, y has to be 0 as well. Okay, so I'm going to put here that if x is 0, y is 0. Now, what? Equation 3, right? What happens in equation 3, though? Equation 3, you have 0 plus 0 equals 16. That doesn't equal 16, which means what? That 0, 0 is not going to be a point that I'm going to look at, right? I'm going to throw it out. So have we considered everything? If x wasn't 0 and y wasn't 0, we got one answer, right? If we let x be 0, it forced y to be 0, and then we said that didn't work in equation 3. If we let y be 0, x will be 0, and it won't work in equation 3, right? So it looks like we only have one answer. I thought Lagrange was supposed to give you the max and min. This is saying that we either have the max or the min. We don't know which one it is yet. Okay, so how do we figure out what the max or min is? So let's do this. I'm going to take f of 2, 2, right? That's my point here. Plug in 2 into the original function, you get e to the 4th, right? E to the 4th. Now, what I don't know is whether or not this is a max or min. Any guess as to how I can figure out if that's a max or min? No. The Lagrange is kind of doing that for us. How do we distinguish between the two? No, not the sign. It could be e to the 4th. It could be... How about this? Can you find me another point on this curve? Remember, we're trying to find the max or min, right? You're looking at this surface restricted to this domain, right? Can somebody give me another point on this domain? Something. I want something that satisfies this equation. 4. How about, let me force it. Okay, I'm going to force you to give it to me. How about if that's true? If x is 0. Y is 0. Then what's x? Cube root of 16. Okay. Do you all agree that this is in the domain? Do you agree I could plug that then into this? And it would be on the curve? Yes? All right. Let's do that then. What is the original function evaluated at that point? E to the what? E to the 0, which is 1. So remember, we were saying, look, Lagrange tells us this is either a max or min. I don't know what it is. But I found another point on the domain, in the domain, I plugged it into the function, and I got the answer is 1. What's bigger, e to the 4th or 1? E to the 4th. So that means that has to be a max. Because if it was a min, right, then this would have to be smaller than this. So that means this is a max. I hope that makes sense to you. Now let me show you the geometric idea here. So this is the surface that we were looking at, e to the xy. That's the surface right there. And what we did is we restricted our domain to this really kind of cool curve on the ground. That curve right there is actually the curve of x cubed plus y cubed to 16. And if we plug just the points along that curve into our surface, we get this curve along the surface. I'm going to pull this out of here. We get that black curve right there. This black curve is what we get. And we found e to the 4th was the highest point. And we knew that because we picked another point on this black curve and we saw that the value was 1, which is obviously less than that e to the 4th. All right.
So in proving it, we know you don't have to try to check both sides of our point because we know that it has to be either a max or a min. So
It has to be a max or min.
okay.
So we can evaluate our function at any other point within our domain restriction, within the constraint, then if that number comes out to be smaller than that, then we know it's the max. If this number was bigger than that, we know it's the min. That's how you deal with if you only have one answer. If you have two answers, then it's going to be obvious because you compare them to each other. All right. I think the algebra has been okay so far, like nothing too crazy algebra-wise. Maybe just knowing where to go, right? Like knowing what to do, but nothing too extreme. All right, there it is. So, first equation. Partial f with respect to x equals lambda partial g with respect to x. All right, this all depends on how comfortable you are with differentiation, right? But for differentiating this, we can do them separately, right? And 1 over y is a constant. So derivative of that's 0. That derivative is going to be what? Negative 1 over x squared, right? Negative 1 over x squared. Negative 1 over x squared equals lambda, okay, partial g with respect to x. Kind of the same story over here, right? Derivative of that 0. Derivative of that with respect to x is negative 2 over x cubed, right? So I'm looking at that as x to the negative 2 and then doing power rule, right? Negative 2 comes out, subtract 1 from the power, x to the negative 3, yeah? And then same thing on this one. Ooh, that's not looking very nice. Okay, we continue. Equation 2, pretty similar, right? Partial f with respect to y equals lambda partial g with respect to y. it's going to be negative 1 over y squared equals lambda negative 2 over y cubed. Very similar, right? And then our equation 3 is our constraint. 1 over x squared plus 1 over y squared equals 1.
Equation 1, if you divide by negative 2 over x cubed, don't you just get x over 2?
When you divide by,
Divide both sides by negative 2 over x cubed.
uh-huh,
That flip, and then you end up getting just x cubed over negative 2x squared.
Would you have to assume x is not 0 to do that?
good question. So to answer your question, yeah, it's going to clean up. I'm not sure exactly what you said. X over 2. Okay, yes. Now, do we have to say x can't be 0, though, to do that?
X is not the denominator.
Because,
After you solve it, x is not the denominator.
yes, but when you divide by this, you're dividing by this is the same as multiplying by the reciprocal, right? So you are actually multiplying by x cubed. So we have to assume it's not 0, right? Or do we? For this problem, do we really have to say x can't be 0? Why not? It's implied in the domain of the original function that x and y aren't 0, right? I mean, look at the domain of the original function. X and y aren't 0. Or else this thing's not defined, right? X and y can't be 0 here as well. So it's understood that in the domain of the original function, we're not going to consider x and y to be 0. So I think it's safe for us to manipulate both sides and not have to say, like, this is a special case, because we already know that it can't be 0. Is that all right with you? All right, so then, yeah, I'm okay with that. Let's solve. So you're saying you want to solve for lambda, yeah?
Yeah.
Okay, so let's take that equation 1. Let's take equation 1, solve for lambda, and you should get lambda is x over 2. Everyone clear with that? Multiply both sides by x cubed, negative x cubed over 2. Similarly, equation 2 tells us lambda is y over 2. You want to set them equal? So x over 2 equals y over 2, so obviously x is y. And then you can go to your third equation, can't you? So you go to your third equation, you get 1 over x squared plus, I'll replace the y with x, so 1 over x squared equals 1. And then combine those together, you get 2 over x squared equals 1, which means that 2 equals x squared, which means x is plus or minus root 2. All right, so we solve for lambda on each equation 1 and 2. We set the two lambdas equal to